Last time I discussed about the octate, incomplete octate, expanded octate. Octate no more is perfectly explanation for the stability of the compounds, but at the beginning level we can consider the octate concept. As a part of your syllabus, we are going to study the levis acidity of different compounds. Before discussing those compounds, let me explain what is meant by levis acidity or levis concept. Gian Levis, a scientist, put forwarded his idea about the acid and base. What people at that time were considering Arrhenius concept, Lowary Bronstead concept. So that concept was related to H plus ion, conjugate acid base concept. But Lewis said there are compounds which can give lone pair. Lone pair means a group of two electrons, pair of electrons, and that pair of electron can be given, and there are compounds which can accept pair of electron. I like to ask you the question, student. If I consider any one orbital, say s orbital or px orbital or py orbital or pz orbital or dx square minus y square orbital, dz square orbital, in that one orbital, how many electrons you can accommodate? Yes, Shubham, right. 2 electrons. Yes, Gaurav, Akshay, good. 2 electrons. So capacity to accommodate electrons in one orbital is 2. So there are molecules which have 2 electrons in their one of the orbital. It may be hybrid orbital, it may be the non-hybrid orbital. Forget about that. Only think about orbital. And there are the compounds which have empty orbitals or vacant orbitals. So it is true now, those who have the vacant orbital, they will tend to take electron. They will tend to accept electron. And those who have the fulfilled orbitals, those who have the free lone pair of electrons, those orbitals will give lone pair. So few are lone pair donors and few are lone pair acceptors. As per Levis concept, lone pair donors are Levis bases. Levis base means lone pair donor and Levis acid means lone pair acceptor. So in terms of the Levis concept, acid means lone pair receiver, lone pair taker, and donor means lone pair giver. Our point of emphasis here is a Levis acid. So what do you think, student? In order that compound should be Levis acid, what should be there in that compound? If it has to accept lone pair, then what should be there? Gaurav has given answer. Can anybody give answer? Listen carefully, my question. In order that compound should be Levis acid, what should be there in that compound? I told you, Levis base means lone pair donor, Levis acid means lone pair acceptor. So in order compound should be Levis acid, what should be there? Akshay saying lone pair positive charge and Gaurav was saying empty orbital. See, lone pair, this pair is of whom? Electron. Electron has negative charge. So lone pair means charge will be negative, electrons will be there. So molecule is positively charged, then it can attract what the lone pair, that I understand. But what basically should be there? There should be the room. If you go to the Mumbai to your relatives, you will not find that much space available. But if the mumbaikar come to Kudar or mumbaikar come to our place, then we have somewhat more space relative to them. So we can readily accept them. So as Gaurav said, in order compound should be Levis acid, what should be there? There should be room. There should be empty orbital, vacant orbital. Then only compound can accept the lone pair. It is the essential condition. I repeat, in order compound to be a Levis acid, there should be empty or vacant orbital, as Gaurav has answered. Students, are you following what Gaurav is saying? Good, good, you are answering. Now we have to come to the different elements and their electronic configuration. Representation of their electronic configuration block diagram. So be with the book and the pen and you have to write down that electronic configuration. When I ask, at that time you have to do. But before that, let you know that electronic configuration. Now pay attention. In front of you, electronic configuration of the various elements is there. First one, boron. Atomic number is 5. Its electronic configuration is 1s2, first shell. Second shell has two orbitals, s and p. S orbital can accommodate 2 electrons, therefore 2s2. And now left only one electron, and that will go in one of the p orbital. That is a 2p orbital. 1s2, 2s2, 2p1. Students, now I am presenting, so I could not read the chat messages. So you have to talk now by unmuting. Is the electronic configuration of boron clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. So 1s2, 2s2, 2p1. Wherever 2 electrons are there, those are paired. And that one pair, that's a lone pair about which I am talking about. 1s orbital has lone pair. 2s orbital also has lone pair. 2p orbital has no lone pair. One unpaired electron it is with. Outer orbitals electrons, if they are there, then those electrons cannot go out. And surprisingly, what happens during formation of bond, more unpaired electrons are made available. Why? I come to that point later on. Now see the second element, electronic configuration. That's a nitrogen. Atomic number of nitrogen is 7. So its electronic configuration of 1s2, 2s2, 2p3. 1s orbital 2 electrons, that's a pairing. 2s orbital 2 electrons, pairing. And 2p orbitals 3 electrons are there. But as per Hund's rule of maximum multiplicity, last year syllabus, electron will prefer window sheets, and after fulfillment of all window sheets, then pairing will be there. So 3 2p sublevels are there, 2px, 2py, 2pz. So first electron in one window, second electron in second window, third electron in third window. So 3 unpaired electrons are here in nitrogen. If you come to next element, oxygen, atomic number is 8. Its electronic configuration 1s2, 2s2, 2p4. In block diagram, how can you write the electronic configuration? Paired electron in 1s, paired electrons in 2s. Now 4 electrons are there. First electron in first window, second electron in second window, third electron in the third window, and fourth electron will pair with the electron which was in the first window. There is no alternative. As like north and south pole remains, likewise the pairing of the electron occurs. It is as per Pauli's exclusion principle. So if you see in oxygen, 2 unpaired electrons are there. Likewise, if you come to the fluorine, atomic number is 9. Electronic configuration 1s2, 2s2, 2p5. I come to the last, that's a 2p orbital. 5 electrons should accommodate. First electron in first window, second electron in second window, third electron in third window, fourth electron will pair with the electron which was in the first window. Fifth electron will pair with the electron which was in the second window, and one electron is unpaired. Come to the last element, that's a neon. Atomic number 10. Electronic configuration 1s2, 2s2, 2p6. I come to the last, that's a 2p orbital. First electron, first window, second window, third window, fourth electron neighboring to the first window electron. Fifth electron neighboring to the second window electron. Sixth electron will neighbor to the electron in the third window. That's the electronic configuration of neon. There's a no unpaired electron. As per our basic concepts of covalent bonding, sharing of electron takes place. One electron from one atom and one electron from the other atom. Because of that, the covalent bond is possible. It can be pure covalent bond, or it can be the partial covalent bond or polar covalent bond. If element is same, atom are of the same element, electronegativity is same, then we say generally pure covalent bond. But it doesn't remain 100% pure covalent bond. They remain a partial ionic character. But I am not going deep. Only just I am asking you to consider covalent bond obtains by means of sharing. Sharing occurs because of one electron from one atom and one electron from other atom which are involved in the bonding. Means if I consider water, formula of water is H2O. Central atom is oxygen. So oxygen can form the bond with the hydrogen. One electron from oxygen will bond to one electron from hydrogen to form one OH bond. Likewise, second electron from oxygen and one electron from hydrogen will form the second OH bond. Just wait. So depending upon the unpaired electron number of bonds, we can decide, we can discuss. So we say oxygen means can form the 2 bond. Chlorine can form the only 1 bond. Hydrogen can form the only 1 bond. Nitrogen can form the 3 bonds. On what ground we say that? on the basis of electronic configuration. But here chemistry always deals with the profit. More number of bonds means more satisfaction will be there, more stability will be there. But in order to obtain the more number of bonds, those many unpaired electrons should be available. And in case if they are not available, then element will think, is it possible to make more unpaired electrons available? Because to make more number of unpaired electrons available, some energy to be utilized. Only just listen. After giving the example, the concept will be clear. But what I am saying, chemicals are always in the profit. They are the good businessmen. Whatever the unpaired electrons are there, with that they can form the bond. But in case if more bonds are to form, then energy to be utilized to excite the electron in what the other orbitals. If orbitals are empty, then only excitation is possible. But provided it is profitable business. Now see, neon. Answer for my question. How many unpaired electrons are there in neon? I am presenting, so you have to talk.
0.
0.
0.
0. No one.
Right, no one, zero unpaired electron. So neon is
0.
very noble. Neon does not want to interact, does not want to react with any other body. It will not form the bond. It is not, it's a natural tendency. It is a noble gas. Forget about it. Now come to the next element, that's a fluorine. Answer for my question. How many unpaired electrons are there in fluorine?
1. 1. 1.
1.
Right. So fluorine will form one bond. It's its tendency to form one bond, single bond. Why? Because giving one electron from itself and taking electron from other, so that what happens, whatever the one electron, it is lagging compared to the neon, compared to the stable electronic configuration, compared to time being considered octet concept, it needs only one electron. So sharing will what prefer. Fluorine will give one electron and will take what the one electron. So sharing by means of, so it can form one bond. Therefore, whenever the fluorine remains, chlorine remains, bromine remains, we show what the only one bond. Exceptions are there. I am coming to that later on. Higher oxidation is possible, but general way, fluorine will form the only one bond. Now come to nitrogen. How many unpaired electrons are there on nitrogen?
3.
3.
3.
3. 3.
Right. 3 unpaired electrons are there. So nitrogen should prefer to form how many bonds? 3 bonds. Example, NH3, ammonia molecule, where you are finding nitrogen can form the 3 bonds. Okay. Now our main element, boron. Answer for my question. How many unpaired electrons are there in boron ground state electronic configuration?
1.
1.
1.
Right, 1 unpaired electron. So what is our expectation? As like fluorine, boron should form only one bond. So if boron is forming a bond with hydrogen, compound hydrogen, so formula for that compound should be BH. If it is a forming compound with chlorine, BCl, with fluorine, BF, with bromine, BBr. It is our expectation from this electronic configuration. But are you finding that BBr, BCl, BF or BH? Have you heard such names?
No. No. No.
Yes. Means it seems like absurd, BBH. On the other hand, which name you heard? BH, compound with hydrogen, BH, or BCl?
BH3.
Right. You heard BF3, you heard BCl3, you heard BH3. Means boron is forming 3 electrons, or boron is forming 3 bonds. Means boron should be with 3 unpaired electrons. Here it is not there, but boron is doing some calculation. Boron has some other business calculation. What boron is doing? Boron is doing some rearrangement. Boron is doing some excitation. And for that excitation, boron is investing money. Boron is investing energy and doing that excitation. But what achievement boron is going to do? In spite of 1 unpaired electron, boron is making 3 unpaired electrons. And due to that 3 unpaired electrons, it is going to form 3 bonds. Now, which electron boron can excite? So far, electrons are there in lower energy level 2s, 2 electrons are there, and 1s, 2 electrons are there. What do you think? Which electron is excitable? Which electron is promotable? Which electron is transferable? Relatively easy.
From 2s. 2s.
Right. Nearest energy orbital, that's a 2s. whichever nearest, from that only it will take, no? If you want timing some money from anybody, then whichever nearby who is there or whichever closer is there, means by place, from that you will prefer, no? Instead of getting the money from the other distant place, instead of going to the Kankoli and getting the money, if you are at Kudar, you will prefer to get the money from the nearby place. So nearby place, nearby energy, that is what the 2s. And electron easily can be converted, no? Easily can be moved from 2s orbital to 2p orbital. No doubt, little energy investment is there. Money investment is there to move electron from 2s to what? 2p. Now in 2s, electrons are paired. That pair also you have to break, because pair means as like north and south magnet. It is compact. That pair is to break. And electron has to come in what? The 2p. That rearrangement boron can do. So boron can make 3 electrons available. Students, are you following what I am saying?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now come to nitrogen. Yes, good. Now come to nitrogen. Nitrogen has already 3 electrons available. But in case nitrogen has to make electrons available, then which electrons nitrogen has to shift? Say 2s. But where it will shift? 2p orbitals are already completely half filled. There is no place to make the unpaired electrons available in 2p. So after 2p, which orbital is there? After 2p orbital, next orbital?
Yes.
3s. It should be 3s. And 3s is higher energy level. So electron from 2s shifting toward the 3s, more investment of energy. It will form 5 bonds. But nitrogen is smaller, no? So considering its size also, the business of the chemical formation decided. Therefore, never you heard NF5 or NH5. NH3 you come to know because 3 unpaired electrons are there. If you come to the next element, say oxygen. Oxygen has 2 unpaired electrons, and oxygen has no space available at this moment to excite electron. If electron you have to excite, then you will excite from 2p orbital to 3s orbital. Again, more energy gap, second shell to third shell. It is not. If oxygen could have do that, then 4 electrons would have been available. So as like you are forming H2O as a formula for the compound, if oxygen could excite electron from 2p to the 3s, you would have get the formula OH4 or H4O. But never you heard such kind of compound. Why? Because such kind of the excitations of electron and the availability of unpaired electron is not possible for the oxygen. Therefore, you have not come across that OH4. About fluorine, 1 unpaired electron already is available. But if fluorine has to make more unpaired electrons available, then what fluorine has to do? Fluorine has to excite electron from 2p orbital to the 3s orbital or other orbitals for the electrons if has to make available. So now 1 unpaired electrons are there. Fluorine can make 3 unpaired electrons available, 5 unpaired electrons available. But accordingly, bonding also should be there. Then it is what possible. Here fluorine is what the electronegative, and we are talking about the simple aspect of the bonding at this moment. So excitation of electron for fluorine we are not considering. Easy from 2s to 2p. It's a second shell only. Such excitations only at this moment we are considering. So for fluorine, such further excitation not there. So only 1 bond. For neon, there is no bond. So conclusion, neon will not form a single bond. Fluorine can form a single bond. It's a natural tendency. Nitrogen can form a 3 bonds. Boron, natural tendency is it should form a 1 bond. But since 2s and 2p are nearby, they are neighbors, energy level, little difference is there. Electron will excite from 2s orbital to 2p orbital, and 3 electrons can be made available. Then one can ask a question, Dil mange more, if 5 electrons are made available, then what is wrong? And it's possible for boron, electron from 1s orbital excite to one of the 2p orbital. Electron from 2s also you are exciting. And in addition to that, electron from 1s orbital excite the 2p orbital. Just consider, electron from 2s is excited to one of the empty 2p orbital. Electron from 1s orbital also is excited to one of the 2p orbital. How many unpaired electrons will be there after such 2 excitations?
5.
5.
Right, 5 electrons. But BF5, BH5, BCl5, that also you have not heard. Why? Because excitation of electron from lowest energy, so 1s energy, is not an easy task. Too much investment is there. and that much profit boron is not getting, and therefore it is not. And again, size of boron is smaller. How many can surround around the boron? So that factor also is there. Size factor means electronegativity factor, and the energy needed to excite the electrons in order to make more electrons available. So far easy case is the 2s orbital electron can be excited to 2p orbital so that 3 electrons will be available. And therefore you know the formula BH3, BF3, BCl3, BBr3. Hydrogen has only one electron, so can form the only one bond. About fluorine, we had a discussion, only one electron, so it can form the only one bond. Same is the case for the chlorine and what the bromine. Boron can form 3 bonds. If boron forms 3 bonds and establishes the compound BH3, BF3, BCl3, BBr3, out of that I consider only one, say BF3. Answer for my question. If I obtain the BF3 compound, 3 electrons are involved for the bonding, is there any empty orbital or vacant orbital on the boron?
No.
No.
No, sir.
No vacant orbital. Okay. I am exciting electron from 2s orbital to 2p orbital. How many unpaired electrons are there now in boron?
3.
3 unpaired electrons are there. So those 3 unpaired electrons can form how many bonds?
3 bonds.
Yes. So boron can form compound with fluorine with formula?
BF3.
Right, BF3. In that BF3 molecule, in boron, now, are you finding any vacant orbital? Are you finding any empty orbital? That was my question.
Yes.
Yes.
Only 2 replies I found.
Yes.
Okay, good. Yes, boron is with vacant orbital. Now, which and how? If I consider 2p, one is a 2px orbital, other is a 2py orbital, and third one is a 2pz orbital. Electron from 2s is excited in 2py. So now 3 electrons are there. Which are those? One in 2s, one in 2px, and one in 2py. So whoever has said yes, on what ground? 2pz orbital of boron is there, which is vacant, which is empty. And as Gaurav said, that if empty orbital remains available, then that compound can be
Levis acid.
Levis acid.
yes, levis acid. So BF3, BH3, BCl3, BBr3 can be levis acid because boron, the central atom in those compounds, have one vacant orbital, and that vacant orbital, say, is 2pz orbital. Is this concept clear to you now? What is the concept? BF3, BH3, BCl3, BBr3 compounds of boron, where 3 bonds are there. Those compounds have vacant orbital, and listen carefully, they are levis acids. Is it clear?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Actually, what
Yes, sir.
happens in boron? Boron has to form 3 bonds, and in order to obtain 3 bonds, one concept is there. 2 different kinds of bonds if are there, then hybridization concept, rearrangement of the orbitals as per the demand. Because anyhow, there should be the minimum repulsion. Last year you have studied VS-EPR theory. Here, it is not the application of VS-EPR theory. We are talking about the valence bond theory. We are talking about the hybridization concept. If 4 bonds are there, then you understood sp3 hybridization. If 3, then sp2. Are you following what I am saying?
Yes, sir.
Yes. Yes, sir.
2 bonds are there, then sp hybridization. Now the compound in our discussion is a BF3 or boron compounds, where 3 bonds are there. In order to obtain those 3 bonds, there should be sp2 hybrid orbital. By yellow color, the sp2 hybrid lobes are shown, and in those hybrid lobes, unpaired electron will be there. So it is one of the hybrid sp2 lobe. Here one unpaired electron will be there. Second unpaired electron in second hybrid lobe. Third unpaired electron in third hybrid lobe. It is a case of boron, and this hybrid sp2 orbital will overlap with hydrogen 1s orbital, or fluorine 2pz orbital, or 2px orbital, 2p orbital, any orbital you can consider, fluorine 2p orbital, so that there will be the boron, hydrogen, boron, fluorine, boron, fluorine bond. Here diagram of the orbitals of boron is shown. Yellow colored orbitals are sp2 hybrid orbitals. I said no, three orbitals are there. One is a 2s orbital, other is a 2px, and next one is a 2py. Those three orbitals are with the unpaired electron. But what boron does? Boron shows the wiseness. Boron orbitals undergo hybridization. They mix orbitals. They decide we are going to form a bond. No, let us unite. So they unite. Which orbital? 2p orbital, 2px, 2py, and 2s orbital. All they unite and they rearrange. Their energies previously were different. Now their energies can be what the different, but generally what we consider their energies are what the same. Their rearrangement takes place. They arrange themselves in such a way that there will be the minimum repulsion in case bonding is going to occur, and certainly bonding will occur because hybridization, purpose of hybridization is to form a bond. Three fluorine guests are coming. In order to welcome those three fluorine guests, there should be three unpaired electrons. In order to make the three unpaired electrons available, electron from 2s orbital excites in the 2py orbital, and after excitation, rearrangement or hybridization of the s and 2p orbitals takes place, and they arrange in this fan kind of arrangement, as like the ceiling fan remains, no? Three blade fan, any three blade fan you consider, the angle between the blades of the three blade fan will be 120 degree separation. If sp3, then 109.5 degree is approximately. If sp2, then 120 degree. If sp, then they will be completely opposite, 180 degree. They can't be with 90 degree separation. There will be the 180 degree separation. It is what the basis of the hybridization and angular separation. Is it clear? sp2 hybridization and the angular separation?
Yes.
Yes, sir.
Okay.
Yes, sir.
Yes.
Yes,
Now
sir.
see, perpendicular to that sp2 hybrid orbitals, what the plane of the fan is there, no, plane of the yellow blade is there, perpendicular to that, blue lobes are there. Blue orbital is there. That is the one of the p orbital. Let us say in case of boron, it is a 2pz orbital. Same diagram is shown, only what rotation is done. Those lobes at 2pz orbital, that's the blue lobes are pointing towards us, and the p, that's the sp2 orbitals, yellow lobes, those are in the plane of the screen. Anyhow, this pz orbital or blue orbital is perpendicular to this sp2 hybrid orbital. Answer for my question. This 2pz orbital, is it with any electron in case of boron?
No.
No. No.
Yes,
No.
it is with no electron, and that is our interest. It is with no electron. So when any lone pair donor will come, say ammonia comes, the nitrogen in the ammonia which has a lone pair, that lone pair will be welcomed by this blue orbital, will be accepted by this blue orbital if it is going to form a adduct or the coordinate compound where lone pair bonding is there, and in that case BF3 will be Lewis acid. And to that BF3 Lewis acidity, additional explanation is, if you see the octate rule or total number of electrons around boron, as we discussed in the last lecture, boron outermost orbital has 3 electrons. From 3 fluorine, it can get 3 electrons. So now property of boron is 6 electron. Octet is not completed. In order to get those 8 electrons, it is in want of 2 electrons. And orbital is only 1. So it will take lone pair. So because by taking that lone pair, its octet also can complete and it will get stability. Means what? BF3 is electron deficient. It is lagging the electron, and it is electron deficient, so it is a vigor to take the electron. As like HCl is a H plus containing compound, it has vigor to give that H plus. NaOH, OH minus and persisting electron, so it has a vigor to take H plus or to give OH minus. So every compound remains with its own mentality, own tendency. So BF3 or these compounds of boron, BH3, BF3, BCl3, BBr3, Bi3, those compounds have the tendency to take lone pair. Therefore, they are lavish acids. So students, till now I told you electronic configuration of various elements, the tendency to form number of bonds, and lavish acid tendency of boron compounds. Is that concept clear to you?
Yes.
Yes. Yes, sir.
Yes, sir.
Yes. Now I come to our
Yes.
regular scene. Now I have to do the advanced study. We understood compounds of borons are the lavish acids, so they tend to take the electron. By the way, in organic chemistry, you studied inductive effect. And as per the inductive effect, electronegativity matters. Now I ask you the question. If I consider halogens, fluorine, chlorine, and bromine, only three halogens at this moment for comparison. Among those three, which three halogens? Fluorine, chlorine, and bromine. Who is more electronegative? Yes, Gaurav, Reena. Fluorine is more electronegative. Right. Then is chlorine. Then is bromine. It's a basic. Good. But how our basic can lead us a wrong conclusion, that I am telling you now. You are absolutely right here. Fluorine is more electronegative. Now answer for my question. If fluorine forms bond with any element, say boron, then tendency of fluorine, tendency of F, to take electron towards itself will be more compared to chlorine, or will be less? Are you following question? If not, then ask me to repeat. Now I'll repeat. Okay, listen. You said fluorine is more electronegative, most electronegative among fluorine, chlorine, bromine, iodine. Accepted your answer. Now I am asking, fluorine is forming bond with boron. Chlorine also is forming bond with the boron. Fluorine is snatching, fluorine is taking, fluorine is receiving, fluorine is greedy to take bonded pair towards itself. Chlorine also has tendency to take bonded pair towards itself. Among fluorine and chlorine, who has more tendency to receive, to take, to greed that bonded pair? Fluorine or chlorine?
Chlorine.
No, not clear audibility. Yes, you can now put message in chat box also. Now I came to the screen. I could read your chat box. Reena has given answer. But Reena, only one student is giving answer out of 21. Pratham is saying chlorine. I want further two answers. Akshay saying chlorine. Gaurav saying chlorine. Gitanjali chlorine. Akshay chlorine. Shilpa chlorine. Janita chlorine. Saurabh chlorine. Mandar chlorine. Okay. Jelina chlorine. All are saying chlorine. See here. It is a basic inductive effect, deals with electronegativity. More electronegativity than induction, or that moment of that bonded pair will be towards that element. And you only have answered no, fluorine is more electronegative. If fluorine is more electronegative, then fluorine should attract bonded pair more towards itself compared to the chlorine. That is electronegativity. While answering electronegativity, you are saying fluorine is electronegative. Will be greedy towards bonded pair of electrons. You are saying chlorine. Surprising. Are you following the conflict? Are you following your different answers? Yes, Gitanjali, Jelena, Akshata. Yes, here was a problem. So now listen carefully. More electronegative the element is, more will be its tendency to take bonded pair of electron towards itself. So fluorine is greedy, more greedy, and it will take bonded pair of electron more towards itself compared to chlorine. Chlorine will take bonded pair of electron towards itself more towards itself compared to iodine. So among those all, fluorine, chlorine, bromine, and iodine, fluorine is most greedy. Fluorine will take bonded electron towards itself. And now central atom is boron. Now consider, boron is bonding with fluorine, the first case. Second case, boron is forming bond with chlorine. And third case, boron is forming bond with bromine, BF, BCl, and BBr. Now answer for my question. In which bonding boron will feel very rare electrons, less number of electrons towards itself? I repeat, BF3, BCl3, and BBr3. These three compounds I am comparing. In BF3, boron fluorine bond is there. In BCl3, boron chlorine bond is there. In BBr3, boron bromine bond is there. Now concentrate on those bonds. In BF3, in boron fluorine bonds, fluorine is greedy, so taking more electron towards itself. Chlorine, comparatively less greedy, will take electron towards itself. Bromine, very less electronegativity compared to chlorine, will take less electron towards itself. Among these all three borons. One boron with fluorine culture, second boron with chlorine culture, and third boron with bromine culture. Surrounding atoms are bromine. Which boron is very poor in electrons now? Which boron will fill less number of electrons? Yes, Akshay, Reena, Akshata, Saurabh, BF3, absolutely right. Because of more electronegativity of the fluorine, because of that inductive effect, the fluorine has taken the electron. So boron is very poor in case of BF3. In BCl3, relatively less poor or relatively rich you can consider. And BBr3, considerably less poor or relatively rich. So among these three, BF3, BCl3 and BBr3, boron in BBF3 will experience less number of electrons. And if less number of electrons is there around boron, then tendency of this boron in BF3 will be more to take lone pair. So who should be the strongest Lewis acid among these three, BF3, BCl3 and BBr3? Listen carefully. Acid means what? Lewis acid means that compound which takes lone pair of electron. The compound which wants more lone pair of electrons or more promptly lone pair electrons, that will be the strongest Lewis acid. In BF3, because of the fluorine neighbor, boron is feeling scarcity of electron. Chlorine relatively less. Bromine relatively less. That is your answer. So as per your answer, what do you think? Who should be the strongest Lewis acid among those three? Yes, Akshay, Akshata, Gitanjali, Saurabh, Shilpa, Gaurav, right. BF3 should be the strongest Lewis acid. It is as per our logic. But to your surprise, your answer is wrong. Chemistry says BF3 is weak acid. BCl3 relatively strong acid compared to BF3. BBr3 further relatively strong acid compared to BCl3. So whatever our inductive effect phenomenon, electronegative phenomenon is there, it is not applicable here. Means somewhere additional thing is there. We are not wrong in our imagination. We are not wrong in application of the concept, but our concept is incomplete. Addition to this electronegativity phenomenon, inductive phenomenon, something is there that we are not carrying, that we are not considering, and due to which BF3 is a weak acid. But many where if you go through search on the internet now, you are find BF3 is a strong acid. It is not the reality. BF3 is a weak acid compared to BCl3, compared to BBr3, and it is because of some additional concept. And that additional concept I am informing to you. Before that, whatever I discussed till now, is it clear to you? Your conclusion, your answer is the wrong answer. You are saying BF3 should be the strongest Lewis acid, but it is not. Are you following where is the problem? Some problem is there. We will discuss that problem now. Good. Now what additional thing is happening? Just imagine now, visualization is very important. What we consider BF3, boron is at center and three fluorines are there. One is towards your left side. One is towards your side, but with angle. One is towards my side, but with angle. 120 degree, 120 degree, and 120 degree is angular separation. These are the sp2 hybrid orbitals. And perpendicular to that, it is our pz orbital of the boron. Could you able to imagine whatever I said? Yes, good. Now, listen carefully and pay attention. This boron pz orbital is vacant, and because of that Lewis acidity is there. What happens? This boron forms bond with fluorine. So this fluorine also has its own orbitals. What's the atomic number of fluorine? 9. Yes, Gaurav, Akshay, 9. So what is electronic configuration? 1s2, 2s2, 2p5, 2s2, 2p5. So in 2p5, that's in 2p orbital, say 2px orbital, 2py, any one orbital which has unimpaired electron, that orbital interacts with whom? Boron sp2 orbital to form boron fluorine bond. I repeat, one of the sp2 hybrid orbital of boron and the 2p orbital of fluorine, they will interact to form a covalent bond, boron fluorine bond. So one of the 2p orbital is involved. What about other 2p orbitals? In case of fluorine, they are free, but they are with electrons. 2 electrons are there, means lone pairs are there. So what is possible when this one of the p orbital, suppose sp2 hybrid orbital, overlaps with 2px orbital. So remaining orbital 2p orbital with lone pair, 2pz orbital is with lone pair, even 2s orbital also is with lone pair, but we are talking about the only outermost orbital now, say 2p orbital, 2px orbital. So other orbitals are there, which in case hybridization occurring, those are not involved. Those are with the lone pairs. So in reality, boron, which has one of the sp2 hybrid orbital, overlaps with the p orbital of the fluorine, and remaining p orbitals of fluorine, they remain unhybrid, or they remain as they are. So that one of the pz orbital of the fluorine and pz orbital of the boron, see, pz orbital of the boron, vacant orbital, pz orbital of the fluorine, filled orbital. Along with this covalent bond, this lateral bond, lateral overlap occurs. Because as more there is overlap, more strong attraction will be there, bond will be strong. Wherever there is opportunity, atoms will prefer that opportunity. So when that interaction takes place, interaction between whom? Empty 2p orbital of boron and filled 2p orbital of fluorine, empty 2pz orbital of boron and filled 2pz orbital of the fluorine, they will interact and they will form the bond. What the situation about electrons? Empty 2p orbital, no electrons. 2pz orbital of fluorine, 2 electrons are there. So 2 electron from fluorine and its empty orbital. When bond occurs, then mixing should be there, river and ocean. When linkage occurs, then water from river can go to the ocean, and from ocean also come to the river to little extent. So we say creek region. It is not always that from river only water goes to the ocean. From ocean also water comes toward the river. So mixing takes place. So when mixing of orbital takes place, then suddenly or certainly the electrons which are there in fluorine, they will go to the boron empty orbital, vacant orbital. Till now we have not considered that. We were considering it is a purely vacant orbital. Now it is not pure vacant orbital. It is with the partial electrons from the fluorine. So its perfect emptiness decrease. So its tendency to take lone pair also will accordingly decrease. So as is the case for boron fluorine bond, same will be boron chlorine, same will be boron bromine. But why the difference? That I have to discuss. Let me make the concept clear. BF3 molecule I am discussing, where sp2 hybridization, one of the sp2 hybrid orbital will form bond with the p orbital of the fluorine. Other sp orbitals, one is towards your side, one is towards my side, but they are making angle. Other than this p orbital of the fluorine, further orbitals are there, say 2p orbital, but all orbitals are filled. Fluorine is in rich of electron. Lone pair is present in that the pz orbital of the fluorine. That lone pair orbital will overlap with empty orbital of the boron, and because of that, electron from fluorine will come to the word boron, not completely but partially, and due to which hunger of boron, tendency of boron to take lone pair will decrease. Our application of the concept was only partial. We are talking in terms of the inductive effect. We are talking in terms of electronegativity, but we not thought about the pi bonding. This kind of bonding is called pi bonding. Or we not thought about the back bonding. We not thought about the pz overlap, 2pz and 2pz orbital overlap of the fluorine. And because of that, as per our previous expectation, tendency of boron to accept lone pair will decrease. Students, are you following what I am saying? Okay, good. Gitanjali, Akshata, Akshay, Reena, okay, all of you are answering. It is in case of BF3. Now what we have to do? We have to compare BF3, BCl3 and BBr3. Now you have to help me. In case of BF3, 2pz orbital of boron is interacting with which orbital? 2pz orbital of fluorine. Now, question to you is, in case of BCl3, 2pz orbital of boron will interact, will overlap, will form pi bond with which orbital of chlorine? Yes, Gaurav, Reena, it's a 3pz orbital, 3pz orbital. See, this 2pz orbital of the boron and 3pz. During combination, no, energetics also matters. In case of the BF bond, 2pz, they are of nearly same energy. So proper mixing takes place. Level point of view means SYBC student can mix with SYBC other students with different subject combination. But SYBC student and MSc student, the mixing energy level is difference is there. It takes time to what the mix. Is a case now. The boron pz orbital, 2pz orbital and chlorine 3pz orbital. So mixing is somewhat poor. Now come to BBr3. In BBr3, 2pz orbital of boron will interact with which orbital of bromine? Yes, Reena, Gitanjali, Akshata, 4pz. So SIBC student is going to interact with PhD student. So mixing will be what? Less. Interaction will be what? Less. Because of difference in the energies of interacting to p orbitals, the tendency of vacant to pz orbital of boron varies. In case of BF3, because of 2pz orbital interaction, that back bonding, that reverse bonding, that pi bonding remains strong in case of BF3. So that vacant 2pz orbital that we are seeing in case of the boron is now less hungry for the lone pair. If you come to the BCl3 molecule, this 2pz orbital of the boron is going to interact with 3pz orbital. Some energy gap is there. So because that thorough interaction is not there, but interaction is there. So relative to BF bond, BCl back bonding pi bond is somewhat weak. So now relative to the hunger of 2pz empty orbital of boron, hunger of BCl3 will be more because pi bonding back bonding is weak. 2pz orbital of boron and 4pz orbital of the bromine, considerable difference in energy is there. Very weak interaction, very weak pi bonding. So compared to BF3, compared to BCl3, the hunger of that 2pz orbital of boron will be more. Hunger regarding what? To accept lone pair, from donor, lone pair donor, and that is our Levis acidity. So true concept of Levis acidity is a measure of tendency of lone pair receiving, lone pair acceptance. And that lone pair acceptance will be more if interaction with neighbor is weak, interaction with neighbor is less. In case of BF3, neighbor interaction is strong, so hunger decrease. In case of BCl3, little increase. In case of BF3, further increase. So among those three, if I have to compare BF3, BCl3 and BBr3, answer for my question, among these three, BF3, BCl3 and BBr3, who is strong Levis acid? Okay, you can unmute and talk. Yes, I'm getting messages here. Yes, right. BBr3 is the strongest. Now unmute and talk. Who will be the weakest Levis acid among those three, BF3, BCl3 and BR3?
BF3.
Right, Gitanjali, BF3, and all other students are giving answers in the chat box. BF3. So what was our previous conclusion? On the basis of inductive effect, on the basis of electronegativity, BF3 should be the strongest Levis acid. But what is the practicality? BF3 is the weakest. And what is the reason for that? P-pi overlap. 2pz and the 2pz orbital of fluorine, 2pz and 3pz, 2pz and the 4pz orbital. It's a pz orbital interaction. So when we consider back bonding, when we consider pi bonding, then this Levis acidity you will understand more properly. So in your syllabus, Levis acidity and comparison of Levis acidity is expected. Now one more compound is there, BH3. Think about that. Next time I am discussing its Levis acidity, BH3. In case of BH3, hydrogen is there, not fluorine, chlorine or bromine. Halogen is not there, hydrogen. So think about that. You guess meanwhile, as I open up the lecture next time, I will ask you, what is your guess? Who will be the strong Levis acid? Whether BBr3 or the BH3, BCl3 or BH3, BF3 or BH3. Likewise, I will ask. So students, today what we discussed the electronic configuration. We discussed the possible covalent bond formation. Oxygen can form 2 bonds, nitrogen can form 3 bonds, boron can form the only 1 bond, but because of the excitation electron, it can form the 3 bonds. Then we discussed the electron deficient compound BF3, BCl3 and BBr3. At the beginning, we applied the inductive effect and we concluded BF3 should be the strongest acid, but reality was different, and that we could explain by means of the pi bonding. In case of BF3, 2p, 2pz. In case of BCl3, 2pz and the 3pz. In case of BBr3, 2pz and the 4pz interaction. And because of the difference in interaction, the levis acidity varies. Is today's discussion clear to you? Any question? Okay, discussion is clear. Okay, students. So today's homework is you have to write the notes of today's discussion and you have to upload in the Google Classroom, and that you have to complete up to next Saturday. Is it clear? Okay, all you are saying yes. Okay, students, then shall I stop? Yes, I stop the recording.